Covalent bonding is bond between two nonmetals.
And it says that sharing between two elements.
Yes.
Sharing of electrons. We call it as sharing of electrons. Like that, the sharing will be taken place.
Oh, okay.
So covalent bond you can tell as the bonding based on sharing of two elements. When the sharing of electrons are taken between two elements, then the bonding will take place. That is called covalent bond. And the second one says ionic bond. What is ionic bond?
Bonding between metal and non-metal.
Metal and non-metal. Okay, very good. The bonding is based on transfer of electrons. When any element, X element is there, that is transferring of element, that is transferring of electron to another element and giving one electron, or transferring, okay, to make it as plus, to make it as minus, and the bonding will take place here from here to here. This bonding is called as ionic bonding.
Okay.
And basically this ionic bonding will form into a salts. But
yes.
covalent bonds which are forming, it forms into a non-polar compounds.
Non-polar bonds.
Which don't have charges at all. They don't have charges. But here you have charges. So we can call this as polar compounds. All ionic bonds are called polar compounds and all covalent bonds are called non-polar compounds. For example, you can write down as CH4 or C6H12O6 glucose. All these things comes under non-polar compounds. And coming to the polar compounds, you can write down as HCl or NaCl or else any KOH. All these things comes under polar compounds. This is the difference between a covalent bond and a ionic bond. Particularly when you see in the reaction format, when we are talking in the reaction format, we can go like this. Now, see here. When I'm talking in the terms of a particular compound, if you're talking about covalent compound first,
yes.
Let us assume a compound called something like PCl5, okay?
Okay.
PCl. Phosphorus, how many valence electrons, outermost how many electrons are there in phosphorus?
Phosphorus, there is
five electrons, okay? Because it's 15, right?
15.
Outermost 5 will be there. Okay?
Okay.
It says the electronic configuration. No, that one 2 valence electrons. How will tell 2, 8, and 5. This is the 5. This is the electrons which will be there. You know how to find this one?
I know.
What is the valence electrons for chlorine?
For chlorine, there is going to be 7.
Yes, exactly. So here 1, 2, 3, 4, 5, 6, 7. Here also same thing. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now make it into a bonding. See how the bonding will take place. See the electrons, how the bonding will take place. Yeah.
Yes.
See the bonding now, how it is. So based on this, you can bond it now. This is called sharing of electrons, and this is the way the bonding will take place in covalent bond. Whereas in ionic bond, it's different. You can see the ionic bond, how it takes. Ionic bond, for example, let me consider with NaCl. Okay.
Okay.
Na is how much, ma? Na is how much? 281, right?
Yes.
And Cl is 287.
Yes.
If I'm losing one electron, it becomes an octet, right? If I'm losing one electron, it becomes too stable. Na losing one electron becomes too stable means it becomes to neon. Neon is what? 280.
Yes.
And here also the same thing. If I gain one electron, very good, argon, it becomes to 288. So losing one electron, it becomes Na plus, and gaining one electron becomes to Cl minus. And this way, this one electron is transferred to here. Due to the transfer, the bonding takes place to form NaCl. Got it?
So what is the difference?
The difference is here you are giving one electron to chlorine.
Yes.
And making him as a stable. By giving one electron to him, he becomes stable. But who is giving? Na is giving. Who is receiving? Chlorine is receiving. And who is donor? Na is donor. Who is receiver? Chlorine is receiver. We need to determine like this. By the plus and minus, both will attract. That's the difference here.
Okay.
Understood?
And over there, covalent shares.
Yeah, here the covalent. This is sharing only. Is not giving. Phosphorus is giving or what? Just is sharing the electron. But this guy is totally giving away.
Yes.
It's totally giving. But this guy is sharing only.
Okay. For example, you're given some question that asks you carbon and oxygen react. What compound it makes? Okay. How do I calculate it? I know it's carbon dioxide, but how do I calculate it?
Yeah, very good question. See here, you don't know what is the carbon and everything, right?
Yes.
See, carbon and oxygen is given, right? You can able to frame it, different compounds you can frame. Either you can form CO, either you can form CO2, either you can form CO3 also.
Yes.
But you need to identify the nature, what is the nature here, whether sharing or not. See here, carbon is double bond O.
Yeah.
And 1, 2, the 2 lone pair is left off. And this is not a proper way of bonding at all. 1, 2, 3, 4, 5, 6, just lone pair only is there like this. But CO2 it says double bond O. 1, 2, 3, 4 is completely sharing of electron. This is also sharing only. This is also sharing. All are sharing, guys. None of the guy comes under, any of the guy comes under your ionic compound. These all are compounds you can frame. That depend upon the what is asking that one. Whether you want CO2 or CO or CO3 framing, you need to frame the structure based on that.
Okay.
But they won't get perfectly element and everything. They will not tell you to identify what is the type of compound, everything. Maybe they can ask you in the formula of empirical or molecular formula, but they will not ask in this term at all.